Hello and welcome to this lesson in quantitative reasoning. We are going to look at the topic of simple interest, the formula of simple interest, and using it in reading problems involving simple interest and answering them. So some of these slides, the ones you see with the navy blue theme, are made by the textbook publisher, so I'll put that up there. I've added a couple of slides here too. They will be a little more sparse in appearance. All right, we're just basically working with the topic of simple interest. We're going to learn how to calculate it. We're going to learn how to calculate interest discounts on a discounted loan, like how much interest you have to pay up front. And then we're going to talk about relative interest rates, or the realistic interest rate, and solving word problems. And all of the interest things are word problems. It's sections of finance that are expressed in words. And hopefully by the time you're through doing these, that won't bother you anymore. All right, we work with money every day. This talks about balancing your checkbook. Even I don't balance my checkbook anymore, but I do check the bank statement and regularly and see what's going on. Calculating a monthly expenditures requires only arithmetic. When we start saving planning for retirement, get a few more formulas involved. The big idea when we talk about either investments or loans is principal. That's how much you either borrow to begin with or invest to begin with. Principal means the beginning amount. And interest is usually expressed as a percent. So if you borrowed $100 from a friend and agreed to repay it in 2 years with 5% annual interest, and remember the 5% means 5 over 100 is the number we use in our formula. R is generally an interest is in a percentage. 100 times 2 years, the amount of interest you pay would be 5% of 100 times 2 years. So there's the principal, the rate, the time. That is how we calculate interest. Principal times rate times time. Okay? So principal is the amount borrowed or invested. The rate is a percent. The rate is always the percent number. And it's usually given as an annual percent. And the time is how long you invest it. Now, in this case, the investment time was years. 5% is assumed to be per year, so that's okay. But if we had said 2 months, you would have had to use 2 months divided by 12 months per year. 2 months would be 2/12 of a year. You have to make sure that the time and the interest rate units match. Interest rate, unless it's stated otherwise, is per year. So there are also variations of this. When we just have to calculate interest, we just simply multiply principal times rate times time, making sure our rate and time have the same time units of years. But what if I have the interest and I have the principal and rate and want to know how long it takes me to make that much money? So the interest is the amount of money I make on an investment. So I would solve for time this way. I would take the interest and divide by the product of the principal times rate. Now, you have to be really careful. When you see I over PR, let's say I is $40, P is $1,000, and R is 5%. I'm just making this up. So R will be 0.05 if it's 5%. 5 over 100 is 0.05. So you say, well, that's 40 divided by 1,000 times 0.05. So in your calculator, you go 40 divided by 1,000 times 0.05. And you get a wrong answer because it'll do the 40 divided by 1,000 first and then multiply by 0.05. You don't want to multiply, you want to divide. You either have to change this to division or find the result on the bottom first, or put this in parentheses. Be aware that even though we can be careless when we're multiplying in a numerator of a fraction, when there are things multiplied in the denominator, you have to put parentheses around it. This fraction bar is an implied grouping symbol. It implies the stuff on the top is grouped together and the stuff on the bottom. We don't always emphasize that enough. So if you're getting wrong answers, make sure you're doing this order of operations correctly, particularly when you have multiple factors or multiple terms in a denominator. It also happens when you have multiple terms. When you're adding, subtracting, numerator, we have trouble with the order of operations sometimes too. But these are not new formulas. The formula is here. I equals PRT. These are rearrangements using algebra of those formulas. If instead of having P, R, and T, I have I, P, and R, and I want T, that's what I do. If I want R, it's I over P times T, and if I want P, it's I over R times T. These are not like 4 formulas to know. You should recall enough algebra that if you have this and you want to solve for one of the other variables, you divide by the remaining 2. But I've written them out here just for your convenience. So the amount of money you have after collecting interest, or the amount of money you owe after a loan is collected interest, is what they call the future value. In this book, we're using A as the future value. But basically, and they say A is the principal times 1 plus the rate times time. That is true, and when we derive the formula for compound interest, we'll see that this is the fundamental premise here. But for these problems, it might be easier to realize that this, if I distribute that big P, is the same thing as saying P plus P R T, and we just learned that this is I, and that's the amount I started with. So the amount you have at the end is the principal plus the interest. You can calculate the interest separately and add it back to the principal you started with. So when you do problems, you may want to do it that way. You may use this formula directly, or the concept is you're adding interest to the amount you started with. So I thought it might be helpful to see it phrased that way. Sometimes, so you have to read your problem. That's the other thing. You have to read your problem. Sometimes a problem will say, tell me how much interest you make, and all you want is this part of it, and all you're going to do is this. But sometimes it's to say, what's the value at the end, and then you want to do this whole thing, or this whole thing. They're the same, okay? So now, a friend asks you to borrow $550 and agrees to repay it with 6% simple annual interest. How much interest will you earn after 6 months? Well, I'm going to tell you right here. I see this months. I immediately know I'm going to, so this is 6% simple annual. That's annual means year, means 1 year. So the interest rate will be 6 over 100. That's where I get this 0.06 from. That's my R. When you do that in your calculator, or when you just do it because you know how to divide by 100, you get 0.06. The time, we have it, here's 0.5. That's because it's 6 months divided by 12 months per year. And if you learn some dimensional analysis in some other class, maybe another math class or science class, what you learn is you can work with the units. Months over months divided by years is the same as the way we divide fractions is months times 1 year over a month, and the months reduce. I'm just scribbling this, but you don't have to take my word for it. When you divide months by months per year, you get 0.5 years. You need that time to be in years if the interest rate is in years. So we multiply the 3 numbers. This is the P, this is the R, this is the T adjusted to be in years. We don't use 6 there. We will get a wrong answer. We want half a year, and you get 16.5. It really $16.50. We're talking dollars and cents. We usually keep that second decimal place to show it was an even 1650. It wasn't 1652. It wasn't, because we count out to the hundredths place, to the pennies. So you earn 1650 in interest. So after he gives you back the interest plus the money, what he gives you back is the 550 plus the 1650. So you actually get $566.50 back for lending him $550. That's how interest works. So a little bit more about making the time units match, because these are the places that students make mistakes and have difficulties. It isn't because you don't know how to use that formula. It's because you don't know how to adjust the numbers to make sense in the formula. So interest needs to come out in dollars. And in order to come out in dollars, it needs to be dollars times rates per year times year times a percent per year times years to come out with dollars, because the rate is dimensionless. It's $1 over $1, so it's dimensionless, but it's per year. A percent is dimensionless, but it's per year, so you need to multiply it by years. So if you have the number of months, you will always take the number of months divided by 12 to get time if your interest rate is in years, which is what I intend to do. Now, what if you have other things? What if you have weeks? Well, if you want the number of years, how many weeks are in a year? There are 52 weeks in a year, so the number of weeks divided by 52 tells you the portion of a year. If you had 13 weeks, and you do 13 divided by 52, that tells you you have a quarter of a year, 0.25. You get 0.25 for that. That's of a year. It's a part of a year. 13 weeks is less than a full year. If you had 104 weeks, you do 104 divided by 52, you can see, oh, that's 2 years. Okay, so if it's less than 52 weeks, you're going to get a decimal with a 0 in the ones place. If it's more than 52 weeks, you would get something besides a 0 there. Now, if you're given the number of days, if there's less than 365 days, it's going to be less than a year. So what fraction of a year is it? So let's say 220 days is the amount of time you borrowed the money or lent the money. You would do time is 220 over 365. Okay. Some accounting practices use 360. I don't think this text gets into that, but there are 365 days in a year. I know there's a leap year and that kind of thing. It used to be they rounded to 360 for convenience, and also it made the numbers come out just a little bit better if you were lending money. But 220 over 365 is what we'll use. So, more practice. Carla's savings account earns 5% simple interest. Savings accounts actually got 5% interest when I was a kid. You go back to the 70s, and that's what you got on a savings account. You put your money in the bank, they would give you 5% per year. She starts with $800 in her account. How much will she have after 6 years? So that's written as words. That's 6 years. I have years and years. I'm good. So this is the R. You have to change that to 5 over 100, which is 0.05. 5 divided by 100. 800 is P. So you need to identify what you're given in the 6 is the T. So they used this formula. What you can also do is calculate the interest, because this is really the formula we're learning, and you get 800 times 6, I turn the R and the T around, but multiplication is commutative, doesn't matter. 6 times 0.05, and what you're going to find there is you get $240. Then you can take the original 800 and add 240 to get the 1,040. So if you don't want to use this formula, you may do that. I think in some ways that makes sense to students. So I added the interest to what I started with. So she will have $1,040 in her account. Now, this is something you may not be familiar with. It's a discounted loan. And a discounted loan is one in which the interest is calculated and deducted from the loan amount or paid up front sometimes. Essentially, the interest is withheld by the bank at the beginning, and the remaining amount is what's actually given to the loan recipient. But you pay back the original amount. So we go through a lot of conversation here. So P0 is the original loan amount. I is the interest in the loan. So you calculate the interest on the original loan amount. And then what you take home is this L. So what you take home, the amount you receive, is the principal minus the interest. And that's principal minus principal times rate times time, but principal minus the interest. That's what you need to know for how much you take home. Then there are other things like what's the effective interest rate? It's a little higher than what the actual interest rate was. So when we talk about the effective annual interest rate, we do use simple interest. This is what the book says, but I'm going to show you my way of explaining this. So on a discounted loan, you pay the interest up front, so the amount you actually get is reduced by this amount. And then you pay back the full amount of the loan. So interest is the amount. Use I equals PRT. P is the full loan amount. What you get is something I'm going to call P new. Now, the effective rate is what would the interest rate have been if the interest I paid was equal to the new amount of the loan times rate times time? What did I really pay? So you do this by, so R equals I over P new times T. So this P new is that reduced amount you brought. If you're asked for you got it. If you're asked for the effective interest rate, and sometimes your book puts an E there, it's going to be a little higher than what they told you the advertised interest rate was. Now you use the advertised interest rate. This is the advertised rate, this R. But really, how much interest did you pay since you paid it up front? you didn't really borrow as much money as you think you did. So you have to be careful to put this P new times T in parentheses. I warned you about that before. So let's do an example. That's maybe the best way to explain this. So you take out what they call a discounted loan of $1,000 at a simple interest rate of 4% for 18 months. So here's another twist. This is in months, not years. So you're going to pay the interest up front and take home less than the $1,000. So you calculate how much the interest would be for the 18 months. Now, because it's 18 months, our time is 18 divided by 12. You could just use 1.5. You could do that separately, or you could do it like this. Just do it right in the formula. But you have to take those months and convert it to years. So it tells you the $60 in interest. So you leave that $60 behind when you take the loan home. And this should be an equal sign. This is equals $940. So $940 is really the amount you took home. I'm calling that P new here. So if I want to know the effective rate, your book calls this RE, I take the amount of the interest, which was 60, and I divide by 940 times 1.5. I would like to have you just do that first and write out the 1410. You see 16 divided by 1,410 equals 0.04255. Now that's not the interest rate, because interest rates are, you need to change that to a percent. This is per 1. You need to change it to per 100. So to change it to a percent, you multiply times 100. So you do times 100, and you get that. So I rounded to the nearest hundredth of a percent that I need to round to the nearest hundredth. Maybe it would have told me the nearest tenth, and I would have said 4.3. But if I'm rounding to the nearest hundredth, it's 4.26. So when I multiply by 100, what I get is 4.255. If I round to the nearest hundredth, I want to keep this place. I look to the right, that's a 5, so that goes up by 6. If I round to the nearest tenth, I'm only going to keep that. I look, oh, that's a 5 or above, so this becomes a 3, and I get 4.3%, depending on what the problem asks for rounding. All right, so that's effective rate. So they advertised 4% to you, but the effective rate was really about 4.3%. That would be important if you were comparing different types of loans in different criteria, and to know which was giving you a better rate. So the 4% isn't really the rate. It's really 4.3%. A little sneaky there. Got to watch out for sneaky things when it comes to money. So Michael wants to borrow $8,000, and the bank offers him a discounted loan. This discounted loan means you pay the interest up front over 3 years. Oh, no, this is not the one I did. Calculate how much money Michael will owe. It's not the same one I did, is it? No, it's not. So this would be similar. Calculate how much money Michael will receive. All they asked is how much money does Michael receive. I did the effective rate, which is a little harder, I think. You literally find the interest, and you get that this is $40. Is that true? I don't think that's true. You get the interest, and I'm going to check to see if that's true. And you subtract it. Oh, no, you get $960, not $40. What am I saying? I'm back on my other problem. So you get $960 for the interest. And then you subtract that from the $8,000. If they ask you how much money he will receive, that's all you do. If they ask for the effective rate, then you're going to do this 960 over 7,040 times the time was 3 years to get the effective rate. But they didn't ask for that. They only asked for this. So that's the question you answer. When you do a word problem, it's very important that at the end you go back and see if you answered the question that was asked, not just one you were happy to get the answer to. Okay, sometimes it's another step to do. In this case, there isn't. All right, so now we're back to Carla. Carla wants to borrow $500, and the bank offers her a discounted loan at 3% simple interest over the course of 6 months. What's the total interest? They simply are asking you to calculate the interest. It's $7.50. And they're not giving the money to Michael, they're giving it to Carla. So the total interest is $750, and if they had asked for how much she was given, it would have been $492.50, which is 500 minus the 750. But they asked you to answer this if all they asked you for the total interest. Okay? So interest doesn't just work for loans, it works for savings. It's a little hard to explain this in the era we're in right now in the year 2020, because there isn't much being paid on savings accounts. I think, 0.5%, 0.1%, because the prime lending rate is like at zero. The Federal Reserve has practically a 0% lending rate. Interest rates paid for savings are always a little bit less than interest rates paid for loans, because that's how banks make money. You put your money in savings and they tell you they'll pay you a little more for that, and they lend that out to other people who will pay them even more than they're paying you to borrow the money. And your money is still, some part of your money needs to be in the bank and all that. The FDIC runs all those rules, but savings interest is always a bit lower. And now we're not talking about things like the stock market. We're talking about like certificates, deposits, savings accounts, sometimes a checking account. But we use that same formula if it's simple interest. Okay. So interest rate is again 1% per year. So Margot deposited $15,500 in her bank account will earn 4.5% interest. How much money will she earn in 10 years? Now, maybe this is a certificate of deposit or something. That's a pretty high interest rate right now. But historically, that's not always been a high interest rate. That's been somewhat reasonable. You could find 4.5% interest, particularly if you invest in what we call a certificate type of deposit account where you guarantee you won't touch the money for 10 years. So the interest is simple interest, we're assuming, because there are other ways. It could be compounded interest, where every year they add interest to the interest. We'll talk about that in coming lessons. The principal is the amount invested, and this is wrong. This should be $15,500. The rate is 4.5%. The time is 5 years. So 4.5% is 4.5 divided by 100. When you divide by 100, it moves the decimal 2 to the left, so you get 0.045. Okay, so that's where that came from. Years is good. The time is not 5 years, it's 10 years. I don't know why they wrote that there. But they did a different, they wrote this out for a different problem. This is P, this is R, this is T. This seems to be correct. So her interest will be $6,975. That's a lot. If you want to know how much she has at the end, if that were the question, you would have to add that to that. Okay? So that's an example of that. Sorry I didn't find those mistakes when I actually read these slides. So Susan invested $1,200, $1,200 in a bank account with an interest rate of 4% interest. So 4% is going to be 0.04. How much interest did she earn in 3 years? 1,200 and 0.04 times 3. If you want to know how much money she had at the end of 3 years, you would add that to the 1,200. So those are the basics of using the simple interest formula. I think the most difficult thing for students to understand is that effective interest. I'll try to come up with some examples of that, particularly related to getting your tax return back ahead of time. If you have one of these big tax companies do your taxes, a lot of times they say, oh, and we'll give you, for a $25 fee, we'll give you your if you have a return coming, we'll give you a check for it right away. That's basically a discounted loan. You're paying them $25 in interest, and they're giving you money. So the net you take home is less than you would have if you waited. And usually it's like, if you do your taxes early, particularly, it's like you would get the actual refund from the IRS in like a week or two. Turns out that $25 on a couple $100 is a huge percentage rate interest. It's enormous. So, you got to realize that if you pay $25 in interest to borrow money for 2 weeks, if it's not a real lot of money, that interest rate is large. And these are the kinds of things that are done, and it's not dishonest because they tell you what the terms are. You pay me $25, I'll give you the money today. And it's fairly common knowledge that you would get it certainly within a month or so. It's up to you to decide whether it's a good deal. If you're going to use that money to pay off credit card debt, you might be better off doing something like just letting the credit card debt run for another 2 weeks, because that might actually be a smaller interest rate, which is unusual. All right, thank you for joining me, and I'll see you in the next lesson.